We've heard about some ways of writing definitions of matter, and we found out that matter can be lots of different things. And so in order to make matter easier to talk about, scientists just divide it up into different types. So we can have all matter, or we can use a system of dividing it into types, as we said. And that's what we're going to talk about today. We're going to talk about a system, not the only system, but a system of dividing matter into types just to make it easier to talk about and to understand. So the first thing we can do is take all matter and divide it up into two different types. And the first type is pure substances. So a pure substance is matter that has constant composition. That means if I have a sample of matter and you have a sample of the same type of matter, it has the same chemical composition. No matter if we have a little sample or a big sample, your sample or my sample has the same composition. Another way to say this is that pure substances have definite chemical formulas that don't change with the size of the sample or where the sample is. The composition of a pure substance is the same. So here's an example of a pure substance. These are gold bars, like the ones that I imagine they store at Fort Knox, that the U.S. government keeps. So if you have gold in the form of these bars, or you have gold in the form of maybe a piece of jewelry, the gold in either one of those two things would be the same. Gold is something that is a pure substance. It has a definite composition. In fact, it has a symbol that represents gold. The symbol AU represents gold. Here's something a little bit more common. Baking soda. You may have bought some baking soda at a store or used some in the kitchen. If you bought it in a container like this, or you bought a different brand in a different container, they would still be the same stuff. Baking soda has a definite chemical formula. Here is that chemical formula, NaHCO3, and that's the way a scientist would read that. But all baking soda is the same. Here's an example of something that you probably have not handled. This is a bottle that contains chlorine gas. Chlorine gas is hazardous, but it is used to make many of the things that we use every day and buy every day. So if we had chlorine gas in a container like this, or if we were at a factory that had a big tank full of chlorine gas, the chlorine gas would be the same. It has constant composition. It's a pure substance. In fact, this chlorine gas has the formula Cl2, capital letter C, lowercase l, subscript 2. Chlorine, baking soda, and gold are all examples of pure substances. So matter that does not fall into the category of pure substances falls into the category of mixtures. So some matter is pure substances, some is mixtures. A mixture is a physical blend of two or more different samples of matter. So if we take two different types of material and combine them together and they don't chemically react, then we have a mixture. Mixtures have variable composition. We can put a lot of one thing with a little of another. We can put a little of one thing with a lot of another. It's still a mixture of substances, but they don't always have the same proportions. They can be made in different ways. And we can use coffee as an example of that. So here's a cup of coffee, and we know that at some point somebody ground up some coffee beans and put them in water. So they mixed those things together. And many of us are happy to drink that stuff. The coffee beans themselves are mixtures. They come from plants, and plants in their cells have many different substances. Substances that give flavor and aroma and appearance. Substances that help the plants live and grow and have the characteristics that they have. So the coffee beans are a mixture. The coffee in the cup is a mixture. But this mixture is variable. Here's another cup of coffee, and clearly it looks different. This cup of coffee looks like a design in cream and chocolate on the top, but if somebody came along and you were holding this cup and they said, hey, what you drinking? You'd say, coffee. Still coffee, but it's different. Coffee can be variable. It's an example of a mixture. We can put coffee together with sugar and milk, and we can do that in different ways. It's still coffee. We can use this machine here to make coffee. I don't know if this is espresso or cappuccino. Oops, I didn't mean to move that. But this machine makes a certain kind of coffee, as does the machine in this little picture right here. It makes coffee that's different from this machine. Still coffee, but it can be different. So the mixture that we call coffee has variable composition. So we can take those categories of pure substances and mixtures, and we can divide them up even further. So some pure substances are compounds. A compound is a substance that contains two or more elements chemically combined together in a fixed ratio. Now we can understand that sentence a little bit better, I think, with an example. Here's a chemical formula that most of us are familiar with. H2O is the formula for water. And all water has hydrogen and oxygen in it, and the oxygen is combined in a ratio of 2 atoms of hydrogen, that's what the 2 means, for every 1 atom of oxygen. So if we have a pool of water, like the one in this picture right here, it contains molecules that have the formula H2O. If we have a single drop of water, like the water that's coming out of this faucet right here, it has water that contains water that has the formula H2O. In other words, water is a combination of hydrogen and oxygen in a fixed ratio. Water is a compound. Baking soda is also a compound. It contains some different elements, sodium, hydrogen, carbon, oxygen, combined in a fixed ratio. There's some baking soda right here. We saw a picture of a box of baking soda earlier. All that baking soda has the same chemical formula, 2 or more elements, in this case 4 elements, combined in a fixed ratio. There's another chemical formula. This chemical formula contains copper, sulfur, oxygen. This is copper 2 sulfate. There's a sample of some copper 2 sulfate sitting on a watch glass right there. And if we had some copper 2 sulfate from the watch glass or some from another source, it would still have copper and sulfur and oxygen in the same proportions as this formula shows. In other words, it's a compound. It's got 2 or more elements, in this case 1, 2, 3 elements, combined in a fixed ratio. Some pure substances are not compounds, but are elements. An element is the simplest form of matter that has its own unique properties. A compound we can break down further by chemical action, chemical reactions. But an element we cannot break down into any substances that have unique properties. We can break the atoms of elements down into protons, neutrons, and electrons, but no matter where they come from, the protons and neutrons and electrons are the same. So an element is a substance that's in its simplest form, and it has its own properties. Gold is an element, and it has definite properties. It has shininess and an appearance and the ability to make it into things like jewelry that are unique to gold. And gold can't be broken down into a different pure substance. So it qualifies as an element. And in fact, gold has a symbol, which we saw before. Symbol AU is the symbol for the element gold. Silver is the same way. This is a silver metal made of silver. Silver has its own unique properties. We cannot break it down into another substance that has different properties. Silver has a symbol, Ag. And in fact, these symbols and the names of these substances help us determine whether they're elements, because all of the elements that exist are listed on the periodic table. So the periodic table is something we'll use a lot in chemistry class, and if we know the name of something, we can look on the periodic table to see if it's an element. If we know the symbol for a substance, we can look on the periodic table and we can tell if it's an element. Just as pure substances can be divided up into compounds and elements, mixtures can also be divided into two categories, one of which is homogeneous mixtures. A homogeneous mixture is uniform throughout. Parts of a homogeneous mixture are visibly indistinguishable. What do those things mean? Well, they mean what's in this blue sentence here. A homogeneous mixture looks the same all the way through. If we look at a homogeneous mixture, we cannot tell that it has different parts. So let's focus on the coffee that's in the cup. If we look at this coffee, we can see that the coffee in the middle looks the same as the coffee around the edges. We know that coffee is a mixture of water and ground up coffee beans, but this mixture looks the same all the way through, which makes it a homogeneous mixture. This glass of milk is also a homogeneous mixture. Milk has lots of water in it, but the mother cow's body also adds lots of nutrients and proteins and maybe some fats and things that are good for us and the baby cows to drink. But, so we know those things are mixed together, but this glass of milk looks the same at the top as it does at the bottom. So it's a homogeneous mixture because it looks the same all the way through. Chocolate milk. We know at some point in time somebody had to add the chocolate to the milk, whether it was this little girl or her mother or the people at the milk processing plant. The chocolate milk didn't come out of the cow that way, so somebody mixed in the chocolate. And this milk looks the same at the top as it does at the bottom, same on the left as it does at the right. Now you know that if you mix chocolate syrup with milk, sometimes some of the chocolate settles on the bottom. And if that was the case, we would not have a homogeneous mixture, but I don't think that's happening here. In this case, we do have a homogeneous mixture. So homogeneous mixtures are one category of mixtures, and heterogeneous mixtures are the other. The prefix homo means the same. A homogeneous mixture looks the same all the way through. A heterogeneous mixture does not look the same all the way through. It's not uniform throughout, another way of saying the same thing. If we look at it, we cannot tell the difference between the parts. It's visibly, if we look at a heterogeneous mixture, we can tell the difference between the parts. Let's be clear about that. A heterogeneous mixture does not look the same all the way through. In fact, the parts of a heterogeneous mixture that we can see are called phases. So a heterogeneous mixture has two or more phases. We saw this picture of a cup of coffee earlier. It clearly does not look the same all the way through. We can see the design in cream and we can see the swirls of the chocolate on the top. We'd still say to our friend, hey, I'm drinking coffee, but it is not homogeneous, it is heterogeneous because it doesn't look the same all the way through. This big container of candy is a mixture of different types of candy, and they all look different. So it does not look the same all the way through. In fact, some of the pieces of candy are heterogeneous because they don't look the same all the way through. So we tell whether a mixture is homogeneous or heterogeneous by looking at it. All right, so there we have a system of describing different types of matter. We can break matter up into two different kinds, and each of those two different kinds into two kinds of their own. And it makes it easier for us to describe matter and talk about matter and think about what might happen to matter. Thanks for listening.